everybody, welcome back. In today's video, we're going to discuss the move zeros problem. Now, this classifies under an easy problem in Leetcode. So let's take a look at what the problem is. We'll check out two different algorithms to solve it, and then we'll code it in Python. So let's get started. So this is what the problem is. You're given a list or an array. Now the array has zeros and non-zero elements. So in your output, you basically have to have all the zeros towards the end of your array or list, and all the other elements should kind of remain in place. That means the relative order of the non-zero elements should remain the same. So let's take a look at what are the different ways to solve this problem. Now, so here's what we discussed. So taking the input array given in the question, you have 0, 1, 0, 3, 12, and as an output, you need 1, 3, 12, 0, 0. So if you see the order, the relative order of the non-zero elements here does not change. That means 1, 3, 12 will appear in the same order in the beginning of the array or list, and all of the zeros will be shifted to the end. So let's jump straight into the first logic. Now in the first logic, what we do is we traverse backwards in the list, and if we find a zero, we pop the zero and we append a zero towards the end of the list. So basically we append a zero. Whenever you append, you're basically adding to the end of the list. So the list, basically lists in Python offer inbuilt functions to allow you to pop and append. So the code should be pretty easy. So if you start off with the array given to us, that is 0, 1, 0, 3, 12, and you start with a pointer at 12, right? Now you see that this is not a this is not a zero, right? So you just move to the next, which is 3, and you see this isn't a zero, so again you move back. Now you see this is a zero, so all you do is call the pop function, right? So you just call pop, right? So here 0 gets popped, and then you call the append function, and 0 gets appended towards the end. So your new array would look like, or your new list would look like 0, 1, 3, 12, 0, right? So this is what your new list looks like, and your new element is now 1. Now 1 again is a non-zero element, so you just move ahead, and then you come to the second 0, which is like the first element. You pop that, right, and you pop that and you append it to the end. So you already have 1 0 here, and then you just call the append function and you append another 0. So your new array looks like 1, 3, 12, 0, 0. And since you are now, not at the 0th element, you pretty much crossed the first element, you have to stop the list. Sorry, you have to stop the loop. So this is the first algorithm. Really simple. You traverse backwards. If you see a 0, you pop and you append, right? Really simple. Now the second algorithm is wouldn't say harder. It's pretty much similar. So let's take a look at what it is. So basically, in your second algorithm, you traverse the list forward. So this time you start from the first element, right? You start from the first element and you traverse forward towards the end of the list. If you see a 0, you basically swap it, okay? If you see a non-zero element, you basically swap it with a pointer that you're tracking, okay? So I know this sounds a little complicated, but don't worry, we'll go through it step by step. So just remember that every time you traverse the list forward, and then every time you see a non-zero element, you swap, right? So let's start and let's see how this algorithm actually works. So say I have one pointer, right? I have one pointer, which is my green pointer, which is going to help me traverse through each element in the list. And then I have my red pointer, which is where I want the non-zero element to come in, right? Where I want the next non-zero element. So if I gave you this list and I said, okay, if I give you a non-zero element, where would you put it? So of course you would say that, okay, this list already is in a bad shape. But if you gave me a non-zero element, I would probably put it in the beginning of this list, because I know that all the zeros are supposed to come after, right? So it would be obviously the best place to put a non-zero element would be the beginning of the list, because I want that all of my zeros should come towards the end of the list. So in our second pointer, we are going to be pointing to where the next non-zero element should fit in. So that, assume, is our red color pointer, right? So Yeah, so every time we see a non-zero element, we'll swap with the red pointer. So let's see. Now we're at our first, we see a 0, so we just keep moving. Now we see a 1, right? We see a 1, we know that it's a non-zero element, we have to swap. So we swap with 0, right? So it looks something like this, right? Then we move on. Now we are here, right? This is where the next non-zero element has to come. Our green pointer is pointing to a 0, so we're like, okay, keep moving forward. We see 3, we swap, right? So you swap with the red pointer. So this is what it looks like, right? And our new pointer is now at 12, right? So you swap with the red pointer because it's a non-zero element, and you see the 12 comes ahead. So if you see our output list is already ready, which is 1, 3, 12, 00. So we've basically pushed all of the zeros towards the end by swapping the non-zero elements to the beginning of the list. So in contrast to our first logic, in which we were actually appending zeros towards the end of the list, we are here we are putting all the non-zero elements towards the beginning of the list. So these are the two logics that you can follow to code the move zeros problem, right? So I will actually okay, so here's a code. Okay, it's like really simple. So I don't want to take you through like each line, but if you look at it, actually pause the video and try to guess like which code is for which logic. It should be really easy to guess at, but no problem. Okay, so here you have pop and append, so you know this is our first logic, right? So basically you run a loop, right? So what is important here is here you are running a loop and then you use a range function actually to give it the starting, the end, and the stride, right? So if you have confusions about the range function, go ahead and read the docs. It's like a pretty cool function that you can use to iterate over any iterable object, right? So when you're doing it with lists, we basically use -1 to travel backwards in a list, right? So we know that we have to start from length of nums -1. We want to go all the way to -1, right? That's when we know that we have to stop, and we travel backwards. So we use -1 here. So if you see a 0, pop that element and append a 0, right? So that's our pop and append code. And for the second code, we use pause. We use the pause variable to represent the red pointer that we were discussing, right? And then we use I basically will be tracking every element, right? We traverse the element using I. And we use augmented assignments here to basically swap our elements. So this is how you can actually code the move zeros problem. If you have any questions about the if you have any questions about the code, I haven't gone through it in detail. If you would like that, please leave it down in the comments below. Maybe I'll make another video explaining the code line by line and we can code it together. If you found this video helpful, consider subscribing to the channel. Please like the video and comment how you liked it. Thanks for watching.